In section 2.7 we look at one-to-one functions and inverses. You'll see from this picture that we have two different values, a and b, let's say, in your domain, and when you apply the function to those, if we have a one-to-one function, then they should end up being different values over here. So having different x values leads you to have different y values. That's what this is saying. If a is different from b, then f of a is different from f of b. So if you look at this function, f of x equals x squared, it's an example of a function that is not one-to-one, because if you take f of 3, that's equal to 9, and if you take f of negative 3, that's also equal to 9. So you end up with the same y value for different x values, so it's not one-to-one. However, if you have x cubed, f of x equals x cubed, it is a one-to-one function because there's only one x value that's going to give you a y value of 8, and there's only one x value that's going to give you a y value of negative 8, that's negative 2. If you remember, there was a vertical line test to test if something was actually a function. The corresponding thing to test if something's a one-to-one function is the horizontal line test. You just see if it's possible to put a horizontal line in that will cross through more than one point of the function. If it's possible to do a horizontal line that crosses in more than one point, then it fails the horizontal line, it's not a one-to-one function. If you compare this graph with this graph, you'll see that in this graph we have a horizontal line, and it's only possible to put a horizontal line that goes through one point on the graph. So this is an example of a one-to-one function. The only kind of standard functions, if you remember, there was a sheet that you were given with all the standard functions, y equals x squared, y equals absolute value of x, y equals mx plus c, and so on. The only standard functions that are one-to-one are a straight line. If you have a straight line, you can imagine that a horizontal line will only go through it in one place. There was also the kind of root things, the square root, the cube root, the fourth root of x. All those things, we call them increasing functions, and so if you put a horizontal line, it will only ever cross in one place. And the only other ones were these two here, the 1 over x and 1 over x cubed. Now, if you have a one-to-one function, then it's possible to find something called the inverse function, which is denoted by this f to the minus 1x, f to the minus 1 of x. It does the reverse, it inverses the effect of f. So if f takes x to y, then the inverse will take y back to x. So if you have some function that takes a value x to a value y, the inverse function will take it back to the original value. We'll take the y value back to the original x value. So, for example, if f of 1 is equal to 4, that means that f to the minus 1 of 4 is equal to 1. And you'll see it on this diagram, that the diagram for f of x takes the value 1 and takes it and makes it into 4. So f of 1 is equal to 4. The inverse function takes the value 4 and makes it into 1. It reverses it. So one way of thinking about that is that the inverse, this thing here, the inverse f to the minus 1 of x, if you plug f of x into it, it gives you x back. Or if you plug f of x into the inverse, it gives you x again. They reverse, they undo each other, if you like. Whatever the effect of one thing is, so whatever the effect of f is, f to the minus 1 undoes that effect. Yeah, and this thing here is the definition of the inverse function. that if you plug the inverse function into the function, you'll get x again. And it's possible for us to find easy inverses like this. If you look at this first example, example 2, if you want to find the inverse of 2x, well, just think what's happening when you take x and you multiply it by 2. How could you undo that? What's the reverse? What's the reverse of multiplying by 2? And what we can do, if we think about that a little bit, is, well, if you were thinking of f as being a function machine and taking a value of x, applying some rule to it and making 2x, what's the reverse of that? Well, the reverse would be to take x, to put it into the function machine. The reverse of multiplying by 2 would be to divide by 2, to take half of. So the inverse function would be a half of x. In this next example, the original function is f of x equals 3x plus 1. In other words, you're multiplying the x by 3 and then you're adding 1 to it. You're multiplying by 3 and you're adding 1 to it to get 3x plus 1. So the reverse is going to be, well, you take your x, you subtract 1 from it, and then you divide by 3. Right? You're going in the opposite direction from this original function. So you're adding 1 and then dividing by 3. If you do that, what you should get is x minus 1 divided by 3. Right? We end up with this expression here. Right? It's the x which is and has 1 subtracted from it, so it's x minus 1, and then we divide it by 3.